At this point in the module, we've only talked about double displacement reactions, so it should go that all the very many individual examples in this problem are all double displacement examples. The reactant pairs listed will all result in one of the types of double displacement reactions we've all seen, which are listed here. Sometimes you can determine what type of reaction you have based on the reactants present. Other times you will need to review the products formed to determine the reaction type. But in all cases, you'll need to start with neutral compounds, swap the ion partners, and then end with neutral compounds and a balanced equation that includes the states of matter. If a new solid, liquid, or gas is formed on the product side, then your reaction will fall into one of the first three categories, and you will be able to write a net ionic equation for that reaction. If both products are aqueous, then you don't have a reaction, and you would include no reaction as the reaction type. One of my reactants here is a weak acid, but the other is just an ionic salt, so I can't really say what type of reaction I have without some work. After swapping the ion partners so that the cation from the first reactant listed pairs with the anion from the second compound listed, and the cation from the second compound finds the anion from the first one, I would want to ensure that my product compounds are neutral overall. As everything involved here has the same magnitude of charge, everything should be present in a 1-to-1 ratio. I then need to assign solubility of each compound using my solubility rules. Potassium compounds are always soluble, as group 1 is one of our always rules. The acetate ion is another of our always rules, so a second compound is also soluble. Since both compounds are aqueous, no reaction has occurred. For those that are realizing the second product is just the weak acid acetic acid, yes, that is a weak electrolyte. And yes, we would leave that compound intact if we were writing the net ionic equation for an acid-base reaction. But since it's formed as a product here and should be listed as aqueous, we're going to list this as no important products being formed. Barium nitrate and potassium phosphate are both fairly nondescript ionic compounds, so we need to move towards products to determine our reaction type. After switching partners, making sure the compounds are neutral, look out for that barium phosphate formula, and assigning states of matter, and then balancing the reaction, we see that we have a solid as one of our products. That makes this a precipitation reaction, and we should be able to write a net ionic equation. The ions that comprise barium phosphate are the barium cation and the phosphate anion. Ensure that your net ionic equation is balanced in both charge and atoms. The reactants for this reaction are a strong acid and a strong base. So I not only can identify the reactant type from the reactants, I can also identify the net ionic equation without any intermediate steps. If you can't do that, you'll get there eventually and it's okay. For now, swap your ion partners. Be careful regarding the formulas that you write, make sure you assign the states of matter, and make sure you balance your chemical equation. Then, identify any important products, which in this case is the liquid water. The ions that form that water and the water itself should be part of my net ionic equation. I do need to take care here, as the stoichiometric coefficients will need to be reduced to the smallest whole number ratios possible. Again, my reactants are just a pair of ionic compounds, so I will have to review the products to assign reaction type. My balanced equation shows that I have formed solid copper 2 sulfide. This means I have a precipitation reaction and can prepare a net ionic equation for it. One of my reactants contains bicarbonate and the other is an acid, so I should be on the lookout for an unstable product that can break down further. All of the ions involved have the same magnitude of charge, so my equation is balanced with a single ion of each type. After assigning states of matter, I see that everything is aqueous. At this point, it would be tempting to be done and write no reaction as my net ionic equation. But we cannot, because we should know that that carbonic acid is unstable and will break down further. So a better representation of this reaction is actually this. Viewing this version of the same process shows that we have not one but two important products, and that a reaction has occurred. Because it has, we should be able to write a net ionic equation for it. For that, you'll include both of the important products. Don't panic though, as you just have two reactants that come together to make these products. Another example with two nondescript ionic compounds as reactants. Unless you're solid with your solubility rules, you'll want to move towards products and review those before deciding on a reaction type. Prepare your balanced chemical equation, including states of matter. You'll see that both of your product compounds are aqueous, so nothing has happened chemically. If asked to report the NIE for this reaction, you would simply report no reaction. If you do happen to be solid with those solubility rules, you might have looked at this and immediately said no reaction can occur. Since both of your cations are group 1 elements, when the partners switch, the anions go from being part of one always rule compound to being part of a different always rule compound. The same would be true had you had two always rule anions. The acetate anion takes up a lot of space, so I abbreviated it AC in the formula unit equation. Note that we have a chloride salt as a product. Halide salts are generally soluble, but the lead-2 cation is listed as an exception to this rule and will precipitate from solution. This is a notable exception that you will see quite often, which is why I included it here. Note that you'll also see silver chloride quite a bit. Since we formed a solid product, it's possible to write a net ionic equation for the process. The lead-2 cation will combine with the two chloride ions to form lead-2 chloride. My reactants are a weak acid and a strong base, so I can identify the reaction type as an acid-base reaction, and since I have a weak acid, I'll know that I'll have a reactant-specific net ionic equation. Since I have an acid-base reaction, the products of the double displacement process are going to be a salt and water. Removing the spectator ions leaves me with this as my net ionic equation, but I have to remember to reduce the stoichiometric coefficients to their lowest whole number ratios before I am finished.